subscribe now and press the bell icon. Never miss an update.
Good morning, students. Today I am going to explain another new topic, pollination. What is pollination? What is the importance or significance of pollination? Already you learned in lower classes. The pollination means the transfer of pollen grains from anther to the stigma of pistil is known as the pollination. The transfer of pollen grains from anther to the stigma of pistil is known as the pollination. So now in flowering plants, the both male and female gametes are both non-motile. Male gamete and female gamete. In flowering plants, both male and female gametes both are non-motile. Both are non-motile. How these non-motile male and female gametes, they have to brought together for the fertilization to occur. That is achieved by the special mechanism is known as the pollination. Both are here non-motiles. They have to brought together for the fertilization to occur to achieve by a special mechanism. That mechanism is known as the pollination. In pollination, particularly see here, two types of pollinations are there for landing of the pollen grains. First one, direct pollination. Second one, indirect pollination. In flowering plants, the pollination is indirect pollination. Why in flowering plants the pollination is indirectly pollination? Because the ovules are enclosed by the ovary wall. In flowering plants, the pollen grains is landing on stigmatic lobe. Pollen grains are landing on stigmatic lobe, not directly on the ovule. That's why in flowering plants, the pollination is known as the indirectly pollination. Directly pollination. What is meant by directly pollination? The pollen grains is directly landing on the structure of the ovule. The best example in gymnosperms. In gymnosperms, the ovules are naked. That's why the pollen grains are directly landing on the ovule. In gymnosperms, the pollination is directly pollination. In flowering plants, the pollination is indirectly pollination because the pollen grains are landing on the stigmatic lobe. Okay, so in flowering plants, total how many kinds of the pollination is takes place? So that is the kinds of pollination. In flowering plants, the different kinds of the pollination on the basis of the source of pollen. The source of pollen. On the basis of the source of pollen, the pollination is divided into is mainly three types. First type, autogamy. Or self-pollination. autogamy or self-pollination. So what is meaning here? The autogamy or self-pollination. Auto means in Greek language is self, gamy means marriage. That is like fusion. Autogamy or self-pollination. The transfer of pollen grains from anther to stigma of the same flower. That is known as here autogamy or self-pollination. So generally here the autogamy occurs in bisexual flowers. In bisexual flowers, so when the release of pollen grains and the receptive of the stigma both are synchronized at a time. That time here the autogamy or self-pollination takes place in flowering plants. For example, see, this is one plant, this is another plant. Stigma, these are the anthers. Same, this is another plant, belongs to the same species. The two plants have a bisexual flowers. See. Female reproductive system gynoecium, male reproductive system anoecium. So, see here. What happened here? The transfer of pollen grains from anther to stigma of same flower. It is known as the autogamy or self-pollination. Second one, gynecogamy. What is a gynecogamy? See here, this is known as the gynecogamy. What is meaning here? The transfer of pollen grains from anther of one flower to stigma of another flower on same plant. That is known as here gynecogamy. What happened here? The pollination takes place between the two flowers on the same plant. Two flowers on same plant. That is known as here the gynecogamy. So here the gynecogamy functionally it is the cross pollination. What about genetically? Genetically, the gynecogamy is a self-pollination. Why here the genetically is a self-pollination? Because the pollen grains came from the same plant. That's why here the gynecogamy is functionally cross-pollination and genetically is a self-pollination. Okay, so what is gynecogamy? The transfer of pollen grains from anther of one flower to the stigma of another flower on the same plant. That is known as the here gynecogamy. Second, this is second one. Third one, genogamy. genogamy. See here, this is. It is genogamy. What is genogamy? The transfer of pollen grains from anther to stigma on different flowers, on different plants belongs to the same species. These are same species of the plants. That's why here the pollination takes place between two flowers on different plants belongs to the same species. That is known as here genogamy. The genogamy, both the functionally and genetically cross pollination. That's why here the genogamy is the true cross pollination. Both here genogamy, functionally and genetically, both are cross pollination. It is a true cross pollination. The cross pollination is also known as the allogamy. So these are mainly here the different kinds of the pollination on the basis of the source of the pollen. On the basis of the source of the pollen, that is the three types of the pollination is there. One is autogamy or self-pollination. Second one is the gynecogamy, and the third one is the genogamy. Okay. Next one. What is monoecious plants or dioecious plants? Monoecious plants. And dioecious plants. The monoecious plants means the male and female flowers. The male and female flowers are present on same plant. The male and female flowers are present on same plant. What are the examples? Monoecious, mice, pasture. So in this one, this is a monoecious plants. The male and the female flowers are present on same plant. See, in these plants, monoecious plants, in these plants is prevent which type of pollination? Autogamy. The monoecious plants prevent the autogamy, but not the both. Here see, autogamy is only prevented. Why? Because the monoecious plants contain the unisexual flowers, that is male flower and the female flower. The both male and female flowers are present on the same plant. The unisexual flowers is only prevent which kind of the pollination? Autogamy or self-pollination. Autogamy or self-pollination. That's why here the monoecious plants prevent the autogamy but not the gynecogamy and the genogamy. What about dioecious plants? The dioecious plants here, dioecious plants, the male and the female flowers are present on different plants. Male and female, male plant and the female plant. The male plant is contain male flowers and the female plants is contain female flowers. That's why here the unisexual flowers are present on the different plants. That is known as here the dioecious plants. The example for the dioecious plants: papaya, date form, etc. In dioecious plants, the dioecious plants is prevent which kind of the pollination too. One is the autogamy, another one is the gynonogamy. In dioecious plants prevent autogamy and gynonogamy. In these plants only possible genogamy because the unisexual flowers are located on different plants. That's why here the dioecious plants, they prevent the autogamy, both autogamy and gynonogamy. So this is the information about the different kinds of the pollination. Okay, next one. Consequences for self-pollination. What is meaning here? The consequences means adaptation. The consequences for self-pollination. What are the consequences for the self-pollination is mainly 5 is there. These are devices or adaptations for the self-pollination. First one, monoclony. What is meaning here? The monoclony. Mono means that is one. Here bisexual flowers. What is meant by bisexual flowers? The flower contains the male and female reproductive organs. What are the male and female reproductive organs? That is anoecium and gynoecium. The anoecium and gynoecium, that is both are present in single flower, that is known as the bisexual flowers. In bisexual flowers, when the both anther is release of the pollen grains and the receptive of the stigma, both are at a time synchronized. Otherwise, there is no self-pollination. It is very important point. So, in bisexual flowers, the most of the chances is it takes place with the help of the self-pollination. Bisexual flowers. The bisexuality condition is known as the monoclony. What are the examples for the here monoclony? The best example, P. Next one, homogamy. What is the homogamy? Homo means same type. Homo, same. Gamy, maturity. The both here in bisexual flowers, the male and female reproductive structures at a time mature. Otherwise, in different types are mature, that is not possible for the self-pollination. When both male and female sex organs at a time mature, that is only responsible for the self-pollination. That is known as the homogamy. What is meant by homogamy? The male and female reproductive structures are at a time mature. That is known as the homogamy. Here also the best example for the homogamy P. It is belongs to Fabaceae family or Pea family. Third one, Cleistogamy. What is the Cleistogamy? So generally here the plants having Cleistogamous flowers. What is meant by Cleistogamous flowers? Cleistogamous flowers. The cleistogamous flowers means the flowers do not open at all. Throughout life, the flowers do not open. Such kind of the flowers is known as the cleistogamous flowers. You take here also the member of the Fabaceae family, that is cleistogamous flowers. The flowers do not open because the stamens is enclosed by the, not only stamens and the stigma also enclosed by the petals. Such kind of the flowers is known as the cleistogamous flowers. In cleistogamous flowers, there is no chances for the cross-pollination because the stamens, that is anther, and the stigma is enclosed by the petals. That's why there is no chance for the cross-pollination. Compulsory, that is takes place by the self-pollination. Okay. The cleistogamy, that is the cleistogamous flowers, the flowers do not open at all. That is here the cleistogamous flowers. You take some plants. In some plants like Commelina, Viola, it is common, fancy. Next one, Streptocarpus, oxalis, etc. These are plants contain both the cleistogamous flowers and the chasmogamous flowers. Chasmogamous flowers. Both cleistogamous flowers and chasmogamous flowers. What is meant by here chasmogamous flowers? The chasmogamous flowers means here the anther and the stigma are well exposed to outside. Open flowers. These are the closed flowers. These four plants contain both cleistogamous flowers and as well as the chasmogamous flowers. Chasmogamous flowers. Commelina, Viola and Streptocarpus oxalis. These plants are containing the cleistogamous flowers and as well as the chasmogamous flowers. It is always open the flowers. Open flowers means the anther and the stigma are exposed to outside. The petals are completely open. When the petals is completely open, automatically the anther and the stigma are exposed. Here, the cross-pollination is possibilities there. Next one, what is disadvantage of here the cleistogamy? What is advantage of the cleistogamy? See, first one, the disadvantage of the cleistogamy. So there is no genetical variation. When the continuous self-pollination takes place, the genetical variation is not takes place in the next generation. That is one of the major disadvantages of the self-pollination. What is advantage of the here? The cleistogamous flowers are cleistogamy. In cleistogamy, to assure seed set, the seed set is formed even absence of the pollinators. Even absence of the pollinators also, the seed set is developed in cleistogamous flowers. The pollinators are not required because here the flower is always closed, do not open at all. That's why here the pollinators are not required. So to assure the seed sets developed are formed even the absence of the pollinators. That is the main advantage of the here the cleistogamous flowers. Okay, these points are very important. Advantage and disadvantage of the cleistogamous flowers. Next one. Fourth one, safety mechanism. Safety mechanism. So what is a safety mechanism? It is also the fail-safe device. Fail-safe device. When the cross-pollination is failed in the plants, that is go for the compulsory, the self-pollination. That is the fail-safe device. Okay, that is a safety mechanism. The best example for this safety mechanism, so when the cross-pollination is failed in that flowers, so that is immediately go for the self-pollination. To take best example, potato, sunflower, mirabilis. The fail-safe device in a potato, what happened? The stigmatic lobe is bent on receiving the pollen grains from the anther. That is known as the safety mechanism. So these are the best example for the safety mechanism. Next, fifth one, bud pollination. Bud pollination. Bud pollination means the pollination occur in bud condition, or the pollination occur in bud stage. Before opening of the flower, the pollination takes place in the flowers. The best example for here, the bud pollination, wheat and rice. Wheat and rice or paddy. In these flowers, the before opening of the flower, the pollination takes place. That is known as bud pollination. The pollination occur in bud stage is known as the bud pollination. So these are the controversy for the self-pollination. So which device are responsible for that takes place the self-pollination? These are mainly 5 is there. So once again, first one is the monoclinic, homogamy, cleistogamy, safety mechanism, and the bud pollination. Next, go for the another contrivance for the cross pollination, outbreeding devices. What are the outbreeding devices for the cross pollination? Contrivances for cross pollination. The contrivance for cross-pollination, it is also known as the outbreeding devices. This concept is very important. Already contrivances for self-pollination finished, that is 5. Monoclinic, homogamy, cleistogamy, safety mechanism, and bud pollination. So now the contrivance for the cross pollination, that is outbreeding devices. The first one, diclinic. What is the monoclinic? Bisexuality. What is here? Diclinic means unisexuality. What is unisexuality here? The flowers consist of either androecium or gynoecium. Such type of the flowers is known as the unisexual flowers. Suppose the androecium is there, that is a male flower. Gynoecium is there, that is a female flower. Staminated and pistillated flowers. So here the diclinic means unisexuality. In unisexuality, there is no alternate for the pollination compulsory. Here, the cross pollination is only takes place. So, never chances for the self pollination. Because here both the male and female, the sex organs are present on different flowers. That's why no chance at all the self pollination. It is only possible for the cross pollination. That is known as here diet-cleaning. What is best example here? Diet-cleaning. Vallisneria. It is an aquatic plant. Already known dioecious plants. Papaya, date palm, etc. These are all plants is the compulsory here. The diet cleaning takes place. There is no chance at all for the self pollination. In this condition, compulsory. Which type of pollination takes place? That is known as the cross pollination. Okay. Next device. Dichogamy. Dichogamy. What is here? The dichogamy. The male and female sex organs are mature at the different times in bisexual flowers. So most of the flowering plants are bisexual. In bisexual flowers do not interest for the self-pollination, because when the self-pollination takes place in the flowers, the continuously self-pollination leads to the inbreeding depression. There is no genetical variability. That purpose here, the majority of the bisexual flowers is avoiding the self-pollination. They promote the cross-pollination with the help of this device. What is name of the device? That is known as the dichogamy. What is meant by dichogamy? The male and female sex organs, that is androecium and gynoecium, are mature at the different stages or different timings. So that condition is known as here the dichogamy in bisexual flowers. Again, the dichogamy is of two types is there. One is protandry. Pro means first, and means androecium. Androecium means male reproductive organ. Pro means first, and means androecium. Here, the androecium is mature early than gynoecium. That condition is known as the protandry. It is most common in the majority of the flowering plants. Protandry. The best example for the protandry, salvia. Next one, sunflower. Salvia, sunflower, cotton, capsula, etc. These are the examples for the here protandry. Second one, photogeny. What is meaning of pro means first, gyne means gynoecium. Here which one is first? Mature, that is gynoecium. The gynoecium is mature early than androecium, that is known as the protogeny. The best example for here, it is rare condition. Banyan tree, people, pig, Aristolochia, even the Roses family. These are all examples for the protogamy. Clear? Here, the dichogamy means the male and female reproductive organs are mature at different times. It is of two types, proto-embryo and protogamy. Proto-embryo means the embryo is mature early than gynoecium. Protogamy means the gynoecium is mature early than embryo. This is known as the dichogamy. Third device. Heterostyling. Heterostyling. Hetero means different styles. The difference between the length of the filament of anther, stamen, Next one, the length of the style. The difference between the length of filament of the stamen and the length of the style. That is known as here the heterostyling. The different length of the filament of stamens and the different length of the style. Again, it is when the different levels or different length of the filament of the stamen and the different length of the style is there. So that is maximum avoiding the self-pollination. They promote the cross-pollination. See. Again here the heterostyling, it is of the two types is there same. One is diheterostyling. Triheterostyling. Diheterostyling and triheterostyling. The diheterostyling means di means two. So here, for example, this is one flower. This flower is contain long style and short length of the filament of the stamens. Second one, short length of the style and long length of the filament of the stamens. See here. This is known as the dimorphic flowers. Two forms of the flowers are present on the same plant. That is known as the dimorphic flowers. Such type of the plants generally go for the diheterostyling condition. Diheterostyling means, see here one flower, here one flower is containing a long length of the style and a short length of the filament of the stamens. Here short length of the style and a long length of the filament of the anther. This much of differentiation is there, the height between the stigmatic lobe and anther. That's why these flowers is maximum is avoiding the self-pollination. They promote the cross-pollination. Avoid the self-pollination, promote the cross-pollination. So that is known as the here diheterostyling. The best example for the diheterostyling, primula, Oldenlandia. These are the primula and Oldenlandia. These are best examples for the diheterostyling. What about triheterostyling? These are the trimorphic flowers. Three forms of the flowers are present on the same plant. So what is the three forms? Same here. One is a long length of the style, short length of the style, another form middle length of the style. Three forms of the flowers are there. It also the maximum is avoiding the self-pollination. They promote the cross-pollination. It is one of the device for the cross pollination. That is heterostyly. Total 3 completed: dichloeny, dichogamy, and heterostyly. And the fourth one hercogamy. Hercogamy means here the male and female sex organs are arranged at different levels in bisexual flowers. That condition is known as the hercogamy. To take best example, hibiscus. In hibiscus flowers, these are the stigmatic lobe. They contain total 5 stigmatic lobes. Number of anthers are present below the stigmatic lobe. See. So these are the anthers. Many anthers are located below the stigmatic lobe. See here, the stigmatic lobe and anther, they arrange different levels on the bisexual flowers. That is also one of the physiological barrier is prevent the self-pollination. They promote the cross-pollination. That is known as hercogamy. The hercogamy means the male and the female sex organs are arranged at the different levels in bisexual flower. That is known as the hercogamy. What are the examples for the hercogamy? Already one example is mentioned here, that is hibiscus. Second one, gloriosa. Here in gloriosa, the stigmatic lobe and anthers are arranged in opposite direction in bisexual flowers. Next one, calotropis. Hibiscus, gloriosa, and calotropis. So these are 3 is an example for the hercogamy. Fifth one, self-sterility or self-incompatibility. Self-sterility or self-incompatibility. What is a self-sterility and self-incompatibility? See here, when the pollen grains is landing on the stigmatic lobe from same flower, that pollen grain is not germinated on the stigmatic lobe. For example, see here, this is a stigmatic lobe. For example, this is a S1, that is a species 1. This is another plant, same species. Suppose this is pollen grain S1. S1 means the pollen grain comes from the same flower. This is another stigmatic lobe. It is released bisexual flower. This is, for example, S2. Now see here, when the pollen grain come from the same flower, the pollen grains cannot germinate on the stigmatic lobe. When the pollen grain came from same flower, that pollen grain cannot germinate on the stigmatic lobe. When the pollen grain came from another flower that is belongs to the same species, that pollen grain is germinated. That condition is known as the self-sterility or self-incompatibility. Self-sterility or self-incompatibility. When the pollen grain came from same flower, that pollen grain cannot germinate. That is prevented the self-pollination and that is promoted the cross-pollination. That is known as the self-sterility or self-incompatibility disorder. Both are belongs to the same species. When the pollen grain comes from the another flower of the same species, that is only germinated when the pollen grain came from same flower. That pollen grain cannot germinate on stigmatic lobe. So that is known as the self-sterility or self-incompatibility. What are the examples for here? The self-sterility or self-incompatibility. Example: Passiflora. Passiflora is one of the example for here. The self-sterility or self-incompatibility. Grapes, apple, tobacco. These are all the best example for here, the self-sterility or self-incompatibility. Another one, pollen free potency. The pollen free potency. What is meaning here? The pollen free potency. See here. For example, this is a stigmatic lobe. This is pollen grain comes from the same flower. This is another pollen grain came from the another flower belongs to the same species. Another pollen grain. Same pollen grain, for example. Same pollen grain, another pollen grain. Another pollen grain means that is belongs to the same species. At a time, these two pollen grains are landing on the stigmatic lobe. Stigmatic lobe. First here, which pollen grain came from another flower? That pollen grain is first germinated. That is known as the pollen free potency. At a time, two pollen grains are landing on the stigmatic lobe. What are the pollen grains? One pollen grain came from the same flower. Another pollen grain came from the another flower. So when these are both is landing on this stigmatic lobe, the first one, which pollen grain is germinated? The pollen grain came from the another flower. It is also prevented the which one? The self-pollination and here prevented the self-pollination, promoted the cross-pollination. These are total the 6 outbreeding devices for the cross-pollination. That is dichlomy, dichogamy. Next one, heterostyly, hercogamy, self-sterility and pollen-free potency. These are the 6 outbreeding devices for the cross-pollination. Next one, agents of the pollination. Next one, agents of pollination. So mainly here, what are the agents of the pollination? The agents of the pollination is mainly two is there. One is abiotic agents, another one is biotic agents. Abiotic agents, biotic agents. Again here abiotic agents by mainly two is there. One is wind, second one is the water. When the pollination by the wind, that is known as the anemophily. This terminology is very important. The pollination by the wind abiotic agent, that is known as the anemophily. When the pollination by the water, that is known as the hydrophily. Next, biotic agents. What are the biotic agents means? By the animals. By the pollination by the animals is known as the zoophily. Here different biotic agents are there. For example, by insects. By the insects. Next one, by birds. By bats. By ant. By snake. By snake. See, these are the different biotic agents. So now here the pollination by the insects, that is known as the entomophily. When here the pollination by the birds is known as the ornithophily. When the pollination by the bats, chiropterophily. When the pollination by the ant, myrmecophily. When the pollination by the snake, ophiophily. When the pollination by snake, that is malecophily. See here, these are the agents of the pollination. So pollination takes place by the two agents, that is abiotic agents and biotic agents. What is abiotic agents? Wind and water. The pollination by the wind is known as anemophily. The pollination by the water is known as the hydrophily. These are the here. Among these two agents, the most common agent in flowering plants is the biotic agents. It is very important point. Among these two agents, biotic and abiotic, which one is more dominant? That is biotic agents. The majority of the flowering plants, the pollination takes place through the biotic agents. Among these two agents, the common is biotic agents. One more important point here, abiotic agents, again two is there, that is wind and water. So in these two, among these two, the most common is wind pollination, that is known as the anemophily. Now we are discussing about the anemophily. What is meaning of here anemophily? The pollination takes place by the wind, that is known as the anemophily. pollination takes place by the wind, that is the anemophily. Among these two abiotic agents, wind and water, which one is most common? Wind pollination. Among these two abiotic agent and biotic agents, which one is most common? Biotic agents. So now let's discuss about the anemophily. What is meant by anemophily? The pollination by the wind. That is known as the anemophily. So when the wind pollination takes place in flowers, that flowers is known as the anemophilic flowers. Anemophilic flower. What are the characteristics for the anemophilic flowers? That is responsible for the takes place the wind pollination. See here the characteristics of the anemophilic flower. First one, the pollen grains are lightweight and non-sticky. The pollen grains are lightweight and non-sticky. It is one of the important characteristics of the here anemophilic flower. Second one, the pollen grains here, the stigmatic lobe is a feathery structures and the stamens are well exposed to the outside, because that is easily dispersal of the pollen grains in outside. And when the feathery stigma is there, easily trap the pollen grains from the environment. It is also characteristic of the here the anemophilic flower. The first character of the here anemophilic flower, that is lightweight and non-sticky, and the second one, well exposed stamens. Well exposed stamens. Next one, a large upturned feathery stigma. A large upturned feathery stigma. Next one. So when the flowers or numerous flowers are packed into an inflorescence, the numerous flowers packed into an inflorescence. It is one of the character of the anemophilic flower. Next one, lightweight and non-sticky pollen grains, well exposed of the stamens, large upturned feathery stigma, and numerous flowers. When the plants contain the numerous flowers, that numerous flowers packed into an inflorescence, and a single ovule. The single ovule present in each ovary. It is also one of the important characters. These are main 5 the important characters of the anemophilic flower. It is responsible for the here the easily anemophily. What are the important characters of anemophilic flower? The pollen grains are lightweight and non-sticky. The stamens are well exposed. The large upturned feathery stigma. When the plants contain the numerous flowers, that numerous flowers packed into an inflorescence, the single ovule is present in each ovary. It is the most common in grasses. One more best example, corn cob. To take in best example, this is a mice. This is a male inflorescence. This is called tassels. Hair top. This is a silky stigmatic lobe and a style. This is a female reproductive and a male reproductive. Tassels, male inflorescence and a female inflorescence. See here, this is known as the here. These characters, these are all characters are reported in this plant. That is the males. Okay, this is the characters of the anemophily. The anemophily is most common in grasses. Here monocotyledon. It is also grass species. Okay, right. So next one, second abiotic agent, that is water. That is known as the hydrophily. So what is the hydrophily? Second abiotic agent, hydrophily. What is the hydrophily? The pollination by the water. The pollination by the water is known as the hydrophily. Again, it is two types is there. Hydrophily, hypohydrophily. It is of two types, epihydrophily and hypohydrophily. So what is the epihydrophily? The epihydrophily means, epi means up. The pollination takes place the upper surface of water. When the pollination takes place the upper surface of water, that is known as the epihydrophily. That is known as epihydrophily. The best example for the epihydrophily, Vallisneria. What is Vallisneria? Vallisneria is one of the dioecious plant. The male and the female plants. The male flowers and female flowers are present on different plants. That condition is known as the dioecious plants. So in Vallisneria, it is a dioecious plant. They contain the unisexual flowers. In this one, the Vallisneria, the epihydrophily takes place. For example, this is the female plant. The female plant is containing a long pedicel. This long pedicel, this is a pedicel. With the help of long pedicel, the flowers are arranged on the surface of the water. This is the surface of the water. What about the male? The male plant, this is a male inflorescence. The male inflorescence are present inside of the water. When this male inflorescence is bursting and release of the male flowers on upper surface of the water. These are the male flower. It is a female flower. Finally, here the male flower is a release of the pollen grains on upper surface of the water. These pollen grains carried passively on upper surface of the water and finally reach the stigmatic lobe of the female flower. This type of pollination is known as the epihydrophily. This is complete water. These are the dioecious plant. Here see, the pollination takes place on the upper surface of the water, that is known as the epihydrophily. What about hypohydrophily? The hypohydrophily means the pollination takes place inside of the water. When the pollination takes place inside of the water, that is known as the hypohydrophily. The best example for the here, the hypohydrophily, Zostera. The common name of the Zostera, sea grass. In this plant, one more plant is there, Hydrilla. These are two is the best example for the hypohydrophily. These are two types of the hydrophily. When the pollination takes place by the water, that is known as hydrophily. Here one more important point is that all aquatic plants do not take place, the pollination do not take place through the water. Best example, water arsenic and water lily. In these plants, the pollination cannot take place through the water. Why? Because the flowers are arranged above level of the water. When the flowers are arranged above level of the water, these flowers takes place through the pollination takes place through the either insects or wind pollination. So that's why it is very, very important in most of the aquatic plants that do not use of the water for the pollination. Okay, best example, water arsenic and water lily. Next, what are the characteristics of the here the hydrophilic flowers? The important characteristics of the hydrophilic flowers, here the pollen grains is very long and ribbon shaped structures. It is one of the important characters of the here the hydrophilic flower characters. The pollen grains are very long and ribbon shaped structures. Next one, the pollen grains is carried passively inside of water. The pollen grains carried passively inside of the water. Next, the pollen grains are protected the protected pollen from wetting by mucilaginous covering. It is one of the gelatinous covering. So this gelatinous covering is protected the pollen from wetting. Next one, the flowers not very colorful. Here only the colorful flowers is only biotic agents, not here abiotic agents. Not very colorful flowers. Next one, do not produce nectar. The hydrophilic flowers do not produce the nectars, just like here the Anubhavamantapa, that is insect pollination. So these are the characteristics of the hydrophily. Here also total 5 characters are there. One is the pollen grains are very long and ribbon shaped structures. Second one, the pollen grains carried passively inside of the water. And the third one, the pollen grains are protected from the wetting by the mucilaginous covering. And fourth one is the not very colorful. The flowers are not very colorful. And last one is the do not produce any nectar. This is the characteristics of the hydrophilic flower. Next, go for the biotic agents. Here one more important point is that hydrophilic. This hydrophilic pollination takes place only in limited species only. Best example, the limited species means only 30 species. The hydrophilic takes place only 30 species of the flowering plants. The best example, monocotyledons. So this is the information about the hydrophilic. Next, go for the biotic agents. Here the pollination takes place by the biotic agents by the animals. That is known as the zoophily. The different types of the zoophily is there. Entomophily, ornithophily, chiropterophily, myrmecophily, melacophily, opiophily. So these are all the different the types of the pollination takes place by the different biotic agents. First, now we are discussing about the entomophily. What is meant by here entomophily? The pollination by the insects is known as the here entomophily. The pollination takes place by the insects, that is known as the entomophily. Among all biotic agents, it is a dominant pollination. In this entomophily, the dominant species is 80% honeybee. Amongst biotic agents, it is entomophily is dominant. Other than ornithophily, chiropterophily, melacophily, opiophily. In entomophily, the different kinds of the insects are there. In that insects, the 80% of entomophily takes place through the only honeybees. What are characteristics of the here the entomophilic flowers? What are the important colors here? The important characteristics of the entomophilic flower. First one here, the entomophilic flower is very large size. Why the flower is very large size? Because it is attract the insects. So it is one of the important characters. The flowers are large in size, colorful, fragrant, and secrete nectar. This is important characters of the here the entomophilic flower. Second one, when the flowers are presenting in a small size, this small size is arranged in clusters to form in a inflorescence. That is, the clusters of the small flowers are arranged in an inflorescence. The small flowers are arranged in an when the plants contain these small flowers, these small flowers are arranged in clusters in the form of an inflorescence. Next one, some of the entomophilic flowers is a release of the foul odor for attract the flies and beetles. Some insect pollinated flowers, that is a secretion of foul odor for attraction of some kind of the flies and beetles. Next one, the flowers are very colorful. And fragrance. Next one, they release of the nectar and provide the floral rewards. This point is very important. What is the floral rewards? The floral rewards means, so when the animal visitors is come to the inflorescence or flowers, the flower is provided the nectar or pollen. That is rewarding of the here the animals or the animal visitors. That time the pollen grains are attached to the insect body or animal body, and when that same animal is visiting the another flower, that pollen grains are dispersal or landing on the stigmatic lobe. You take some plants, they providing the safe place for the laying of the eggs. The best example, yucca and Amorphophallus. These are two is the best example for the plants is providing here the safe place for laying of the eggs. The best example you take yucca. Here in yucca, this is the symbiotic pollination. In this plant is depending on one mark that is known as the Pronuba yuccacella. The mark name, the Pronuba yuccacella. It is the symbiotic pollination. The both life cycle is depending on each other. At least one is absent, their life cycle cannot completed. This the Pronuba marked, this one Pronuba yuccacella mark, they deposit eggs in ovary of the yucca. At the same time, when the moth is visiting of the yucca flower, that time the pollination takes place, and further the formation of the seed set. When the development of the seeds, the larvae of the moth comes outside. Even Amorphophallus also same condition. It is also one of the symbiotic pollination. It is one of the here Amorphophallus. The flower is very tallest flower, nearly 6 feet length is there. It is one of the tallest flower in flowering plants. So these are both these best example for the symbiotic pollination. And one more important point is that the pollen robbers or nectar robbers. What is the pollen robbers? Here, the majority of the insects is consume the nectar without bringing of the pollination. Just only consume the nectar, so without bringing of the pollination, such kind of the animal visitors or insects is known as the pollen robbers or nectar robbers. So this is the concept of the pollination. Okay, students. Okay, bye.
Subscribe now and press the bell icon. Never miss an update.